Hello and welcome to this GCSE Chemistry explanation video about electrolysis. This is the first of 3 videos about electrolysis, and this one is going to focus on molten ionic compounds. In this video, I'll take a look at what electrolysis actually is and how we carry it out working with ionic compounds, and we'll finish by looking at how we can predict the products that will form as a result of the electrolysis process. This video covers the foundation tier content. If you're doing higher tier, you'll want to check out my alternative video about this topic. Electrolysis is a process where electrical energy, or we could say an electric current, is used to make a chemical reaction happen. And the word itself breaks down into 2 parts. Lysis means splitting apart, and electro means using electricity. And so together we are splitting things apart using electricity. We use electrolysis for a variety of different purposes, and to give you a few, we use electrolysis to separate an ionic compound into its component elements. We use it for metal extraction for particularly high reactivity metals. We can use it to produce useful chemicals. For instance, hydrogen and chlorine are produced from the electrolysis of salt water. And we also use electrolysis for electroplating. You need to be able to understand and explain the process of electrolysis, and you also need to be able to draw diagrams of the equipment that you use during the process. Typically, in school, you do electrolysis in a beaker, but it could really be any shaped container or any scale of container. Into that beaker will go an electrolyte. The electrolyte is the liquid or solution that the electric current flows through, so it's essential that that electrolyte conducts electricity. Into that electrolyte we place some electrodes. These electrodes also need to be able to conduct electricity, and it's really important that they are inert. That means that they are unreactive. Typically, we'll use carbon in the form of graphite or a low reactivity metal, for instance, platinum. The electrodes are then connected to wires and they conduct electricity and complete the circuit, and the final component that we need is some kind of power supply, for instance a cell or a battery, that provides the electrical energy which is the driving force behind the process. The electrolyte that's in the beaker needs to be an ionic compound. These are compounds made from positively and negatively charged ions. As a solid, the ions are in a fixed position in a giant 3-dimensional lattice, and these ions can only vibrate about a fixed position, and so they can't move, and so they can't conduct electricity. As a liquid, or when dissolved in water, the ions from the lattice are no longer in a fixed position, and so they are free to move around within the electrolyte. This enables them to conduct electricity when an external power supply is connected up. If the electrolyte is made up of an insoluble substance, that means this ionic compound would need to be molten in order for the ions to be able to move. However, if the electrolyte is something that is soluble, we could instead choose to dissolve this chemical in water instead of melting it, and this will use much less energy, and so typically this is preferred. To begin our explanation of electrolysis, we'll first take a look at what happens at the graphite electrodes. Graphite is made from carbon in a giant structure, and because carbon only has 3 covalent bonds in graphite, there is 1 delocalized electron per carbon atom. But since the graphite has the same number of positive particles and these negative delocalized electrons, it is neutral overall. But when you switch on this external power supply, an electric current will flow, and the electrons that are delocalized will move out of one of the electrodes, the one on the left as I'm showing it, and then these delocalized electrons will move through the copper wires, through that to the other electrode, where the electrons will start to build up. This will make the electrode on the right-hand side become negatively charged because more and more negative electrons will be building up there, and so this electrode will no longer be neutral. And then the other electrode, which has lost these negative electrons, will become positively charged. And so now we have two oppositely charged electrodes dipped into our electrolyte. And the electrolyte is made up of an ionic compound with the positive and negative ions that are free to move. And so the positive ion from the ionic compound is now going to be attracted towards the negative electrode because opposite charges attract. And so the positive ion will move through the electrolyte to the negative electrode. And the negative ion is going to be attracted towards the positive electrode, and so we'll move towards that. And this means that there is an electric current flowing through the electrolyte, because electric current is the flow of charged particles. And in the electrodes and in the wires, these charged particles that are flowing through the circuit are the delocalized electrons. But in the electrolyte, it is the ions. And that's the core idea of what happens during electrolysis. And next we'll look at some examples. You need to know about the electrolysis of molten substances, sometimes referred to as melts, and we're going to take a look at lead bromide. In my container, I have my electrolyte, which would be the molten lead bromide. In order to make this molten, we would of course have to apply a high temperature to break apart the electrostatic attractions within the ionic compound. We've got the electrodes that are dipped into the electrolyte, and we've got the wire, and importantly, the power supply. When you turn on the power supply, the electrons will move through the electrode and the wires, and we'll have our positive electrode and our negative electrode. And then electric current will pass through the electrolyte, which is the molten lead bromide. Now, lead bromide contains two types of ion. It contains lead, which is a 2+ ion. All metals will form positive ions, and it also contains the bromide ion, and bromine is in group 7, so when it forms an ion, it becomes bromide, which is 1- as a charge. And the negative bromide ions will be attracted to the positive electrode, so it will move across to the positive electrode, and they become discharged. And in this context, discharged means to have the charge lost or removed. And so that means that in the electrolyte, the ion had charge. Once the substance has arrived at the electrode, the ion gets converted into a neutral element, and so it has lost charge. And so in this case, the bromide ion loses electrons and becomes a bromine molecule, Br2. And since this is taking place at a high temperature, high enough to melt the lead bromide, the bromine that forms will be a gas. And then the positive lead ions will be attracted towards the negative electrode, and they will gain electrons and become discharged as well. Remember, that means they have lost their charge. And they will become the element lead, which will then fall to the bottom of the container as a layer of molten lead. You need to be able to predict the products that will form as a result of carrying out electrolysis on any electrolyte that you are given. You might be given a formula, or you might be given a name for this electrolyte, but all of the electrolytes will be what is called a binary ionic compound. And a binary ionic compound is one made up of just two elements. So one ion will be positive and be made up of one element, and the other element will be negative. Sometimes ionic compounds have got more than two elements in, but this will only be binary compounds. And so if we take a look at three examples, first of all, magnesium oxide. Magnesium oxide has got the formula MgO. Mg is magnesium and the O is the oxygen. But on this occasion, the oxygen is a negative ion, so it will be the oxide ion. The two ions that are going to be present in the magnesium oxide are magnesium. Magnesium will be in group 2, so it's got two outer shell electrons normally, and so when it becomes an ion with a full outer shell, it will be a 2+ ion. Oxygen is in group 6. It needs to gain 2 electrons to become stable, and so it will be a -2 oxide ion. Then we need to remember that the ions will move to their oppositely charged electrodes because that's the one they will be attracted to. And so the positive magnesium ion is attracted to the negative electrode where it gets discharged. And so we'll see magnesium forming at the negative electrode. That means that the oxide ion will be attracted to the positive electrode, and so oxygen will form at the positive electrode. For a second example, let's take a look at zinc chloride with the formula ZnCl2. That formula means that there are 2 chloride ions for every 1 zinc ion. We know that chlorine is in group 7, so it will form 1- ions. To fill the outer shell, it must have gained 1 negative electron to get that 8 electrons. Zinc, therefore, must be a 2+ ion. We can't work that out from the position in the periodic table, but we can work that out because it is bonded with 2 negative chloride ions. Its positive charge must be cancelling that out. And then the positive zinc will go to the negative electrode, and that's where it will lose its charge. It will be discharged. And the chloride ions will move to the positive electrode and will make the element chlorine. And then in a final example, copper iodide is made up of copper and iodide ions in the ratio of 2 iodide for every 1 copper. So the ions will be 1- for the iodide, because again, it's a halogen from group 7, and the copper must again be 2+ to cancel out those 2 negative charges. The positive copper will then be discharged at the negative electrode that it was attracted towards, and the iodide ions will move towards the positive electrode where iodine will form. It's really important to notice that the ions have got a different name ending to the element that forms at the positive electrode. So we had oxide, chloride, iodide, but we made oxygen, chlorine, and iodine, and that's because the ion has a different name ending to the element. It's also worth pointing out that we don't really need to know what the specific ions are in order to work out what the product will be, because all we need to remember is that metal ions are going to be positively charged because they transfer their electrons to the non-metal. And so the positive metal ions will be attracted to the negative electrode where the element will form, magnesium, zinc, or copper in these examples. And then the non-metal, which has gained the electrons, will be a negatively charged ion, and so that's why the non-metal always forms at the positive electrode. And you can see we've got the elements oxygen and chlorine and iodine. Okay, that's the end of this video. Thanks for watching.